Again, I'm Pete Rothers. I'm the Enterprise Solutions Architect, basically the 3-PAR guy for North Central for HPE. So I'm covering pretty much all the North Central states down to Kansas, as far west as North and South Dakota. And I also cover Wisconsin and Illinois. Let's kick into the pre-zone here. Yep.
Okay. Can we have the full screen, please?
So is it full screen now?
Yes. Thank you.
Okay, great. Thank you. So a little bit of marketing information. I'll try to limit this, but it really gets into a conversation about how HP's been gaining a lot of market share. I'm not going to cover hyper-converged or other storage offerings today, but a lot of it has been 3-PAR. If you notice, we're actually #1 in enterprise storage. We've actually surpassed EMC VNX as the primary mid-tier solution out in the marketplace today, and we're growing quarter on quarter. Last I checked, we were approaching 40,000 3-PARs in the field, and we know that because the vast majority of those 3-PAR systems will actually phone home to us, so we have telemetry and metadata on which each one of those systems is doing. A little bit of an idea around the positioning. I mean, we've got a lot of different storage products at HP. 3-PAR is really positioned as that shared storage solution for mid-sized to high-end open system environments. There's a lot of other storage solutions on the lower end, as an example, hyper-converged MSA and Store Virtual, and on the high end for with the Hitachi-based HP technology, the XP7. But in my world, I really don't talk about those other solutions. I'm a unique resource at HPE. I am focused on 3-PAR and 3-PAR only. So let's jump in and talk about the StoreServ a little bit. So everybody's going to show you some Magic Quadrant slides. And you'll notice there's a lot of people that are in the upper right-hand quadrant in both general purpose and flash storage. But what makes HPE different here with the 3-PAR solution is we're in those upper right-hand quadrants for those two different categories with the exact same architecture, the exact same software stack, the exact same feature set, look, feel, the whole 9 yards. Everybody else is going to give you a different architecture view between the flash and general purpose arrays. And again, everybody loves to show these slides of all the awards that they've received. 3-PAR is, and I put this up just for a little external industry validation. Again, there's a reason why 3-PAR is #1 in enterprise storage today. So I'm going to pop to the next slide. And I won't spend a lot of time bashing on competitors, but I would be remiss if I didn't just point out that when you look, and I'll use EMC as an example, there's a lot of different architectures and a lot of different technologies in what EMC offers from a storage, an enterprise storage perspective. All those different storage platforms have different tools, different capabilities, and different architecture, so it adds to complexity. 3-PAR is a little bit different. We have the same architecture, the same operating system, the same feature set, common drive types, and the ability to move and migrate data from the lowest end entry-level platform on the 3-PAR side, the 8200, all the way up to the 2850. And if I took you to the previous generation, the 7000 and 10000 series, that's still the same architecture, the same operating system, the same feature set for the most part. We try to, as we release new capabilities and arrays, we try to push them as far down in the family as possible. We try to port them back to previous generations. It's just going to depend upon the horsepower. But really, again, the differentiation between 3-PARs and the other guys are we're doing this all in one architecture, one software stack, one OS, one common management GUI, and it just leads to a simplicity conversation and an ease of use conversation that just doesn't exist with my competitors. Again, I just popped up an eye chart, and everybody's going to have these. I went and circled one thing I want to have you focused on. It's basically the IOPS and bandwidth numbers. Even in our low-end entry-level platform, when you're looking at that platform from a performance perspective, that platform is actually putting up some pretty good numbers, 10 gig a second at 320,000 IOPS. So our entry-level platforms actually map to our competitors' mid to high-end platforms in a lot of cases. And when you look at what we consider our mid-tier, which is the 8400, 8440, and 8450 series platforms, look at what the numbers are. They're actually competing with the Tier 1 platforms from my competitors. And since 3PAR is the only mid-tier platform out there that goes beyond 2 controllers in an active-active configuration, we actually can, along with performance capacity, we can also have the same availability of mid-tier platforms. So the message there really is when we're competing and we're pitching solutions against our competitors Tier 1, we're not always going up to the big 20,000 series high-end platforms to compete with them. We're frequently looking at 8400 series boxes, and we're directly competing with the VMAXs and VSPs of the world with those platforms. You know, why does anybody care? Because if you can get the same availability, performance, and feature set, but for significantly less cost, that's a really good story. And that's really where we focus. Now with the 20,000 series platforms, people may ask, well, when are you selling the 20,000 series? When people really want to consolidate a lot of disparate workloads, when they want to go to the thousands of servers conversation, or when they need a lot of external I/O connectivity. As an example, the 8400 series platforms only have 24 Fibre Channel ports. They are 16 gig, but they don't have the expandability of a 20,000 series. A 4-node 20,000 series platform can support up to 80 16 gig of Fibre Channel ports, and when you go to an 8-node system, they can support up to 160. So the I/O connectivity on the 20,000 series systems is much higher. And folks ask, well, what's the real difference on 3PAR versus the others? And I go back to a conversation of ASICs. Where do you find ASICs? You find ASICs in high-performance solutions like network switches and Fibre Channel switches, things that move data from point A to point B very, very quickly. Well, what differentiates 3PAR is we have an ASIC in every one of our systems. In the 8000 series, it's a single ASIC per controller. On the 20,000 series, it's dual ASICs per controller. And what do those ASICs do for us? If you look at the slide, they're handling our RAID support. So all our RAID calculations are done in the ASIC. It's handling all our data integrity checking. And for supported HPAs, our host bus adapters, that's data integrity checking all the way from the host bus adapter to the disk and back again. They're handling all our thin and pieces of our data reduction story. They're handling all our data communications and clustering technology between the multiple nodes and the 3PAR. As you can imagine, when you get to an 8-node conversation where every ASIC has a connection to every other ASIC, that's a lot of interconnects. So having that tightly coupled clustering technology controlled by the ASIC is critical. It's also handling our cache mirroring between the controllers. And last but not least, it's handling all the data movement from disk to host and back again. When you look at a typical 3PAR that isn't doing a lot of data dedupe or a lot of DR, the CPUs on the controller nodes are running you know, a 10 to 15% utilization. The ASIC is doing all the heavy lifting. The other thing about an ASIC is when you ASIC can maintain performance under load. When you look at a CPU-based system, which is the vast majority of my competitors. The CPU-based system has a performance curve that's bell-shaped. As you saturate that CPU and you throw more workload at it, the performance will actually drop. In an ASIC, when you saturate it and you throw more workload at it, it'll maintain that aggregate performance. And really, it is an architecture difference. When you look at traditional modular arrays, that's the Pures and EMC, Unity, VNX platforms, they're dual controller active-passive designs. When you look at the typical monolithic array, that's a pretty established mesh technology too. When you look at a 3-power architecture, every controller and every ASIC has a direct connection to every other controller and every other ASIC in the system. So that full mesh active-active controller conversation really differentiates us. Maybe not so much in the high-end systems, but when you look at an entry-level 2-node system, an 8200, that's active-active controllers also, and that really is differentiated from a lot of the competition out there today. And it gets in, and so this slide is kind of giving little communications and how data movement works. The top example is everybody else. Their storage controllers are a bunch of Intel processors and cores flying in close formation, and those Intel processors and cores are doing everything. They're doing all the metadata handling, they're moving all the payloads back and forth, they're doing all the data management, they're doing all the RAID calculations. Everything happens on that CPU. So in those systems, you have to have a lot of cache, you have to have a lot of cores, and you really need to core up those systems. And like we mentioned earlier, when you saturate a CPU-based system, the performance bell curves and decreases. Looking at a 3-power example, the ASIC is handling all the payload. It's moving all the data from disk to storage and back again. The CPU is really handling the exception stuff, the metadata, the data, some of the data reduction pieces. And that really allows us to get a lot more bang out of the buck and not have to have as much cache and cores as some of the other solutions out there. Because yes, the 3-power controller does have an Intel CPU, but we aren't going crazy with it because we don't need to. The ASIC is doing the heavy lifting. And when you look at the 3-part design, everything in that 3-part design is based around the capabilities of the ASIC. And this slide represents, on the left is traditional arrays. It's pools, it's RAID sets, it's that whole conversation. And 3-part is different. We are taking every drive and we are virtualizing that drive in 1 gig segments we call chunklets, which means we can mix RAID levels on the same drive, which also means we have no dedicated sparing. I'll talk about that in a slide or two. And we're striping workload across every drive in that tier in the system. So we're taking advantage of the performance of every drive in the system. It's reservationless. We don't have any dedicated pools. And we can mix RAID levels on the same drive. So it makes it a lot simpler. You don't have to do any manual tuning. There's no playing around with heat maps or shuffling data between different RAID sets to optimize performance. And what it also means is you add more storage to a 3-part solution, the performance gets better over time because we will actually re-optimize the workloads across all the drives in those specific pools as disks is added. So let's talk about how our sparing works. Again, the left side is traditional sparing, dedicated spare, really not used for any of the workload. In the 3-part world, we don't have dedicated sparing. We take spare capacity out of every tier in the system. What that means is when we're doing rebuilds, we don't have to rebuild an entire failed drive. We're just rebuilding the capacity. Not such a big deal when you're talking about flash drives, but when you start talking about nearline drives where you're measuring drive rebuild times on a calendar instead of a clock, it makes a huge difference. It also means that when the system is lightly utilized, we will actually kick up more threads to do our rebuilds faster. The last point I'd like to make is it also means that without those dedicated spare drives, all the drives in the system are being used to service your customer workload. And let's talk about how 3PAR virtualizes. Earlier on, I mentioned that we kind of pieced up every drive into 1 gig segments we call chunklets. So we take those chunklets and we group them into a logical construct called a logical disk, or an LD. Those LDs are owned by individual controllers in the system, whether it be 2, 4, or 8. So not only are we striping across every drive in the 3PAR, we're also striping across every controller in the 3PAR. So we'll group those LDs together into a virtual volume, which will export to your host as a LUN. So, the typical host connected to a 3PAR isn't only leveraging all the disk, it's leveraging all the controllers also. And every 3PAR has a lot of Tier 1 high availability features natively. The first one that and is unique to us is what we call HA shelf. It's the ability to lose an entire shelf from a 3PAR perspective and still maintain performance and access to all the volumes presented to the hosts. That's part of our 6 nines guarantee. We also have cache persistence. So unique to us in the mid-tier, with the ability to have 4 controllers, we can lose an entire controller and not go into a write-back cache situation where we're no longer mirroring write cache and we have to wait for writes to commit to disk before we acknowledge. So we can lose that single controller, still maintain cache mirroring and performance, and still run with very, very little performance impact. And that leads to the persistent ports conversation. So when we lose that controller, not only are we maintaining performance and write caching, we also are not generating a multipathing or path failure event to the host. We will actually take the worldwide name or the connection to that failing controller, and we will transparently fail that over to the surviving controller. Why does the customer care? Because anytime we have to get into a situation where the multipathing software on the host, MPIO, manages a path failover, that could take 30, 60, 90 seconds to resolve in some cases. And what happens in that time is applications time out, alerts are generated, web pages pause, applications don't do what they're supposed to do. The persistent ports conversations happen in milliseconds. So those critical databases and applications only see a very, very short couple millisecond pause, and then they just go on without interruption, without all the drama, without generating all the alerts. And last but not least, having that persistent checksum capability built into 3PAR means that we're doing data integrity checking all the way from the host HPE to the drive and back again. So no conversation about anybody's storage array wouldn't be complete without having a flash conversation. Now I'm going to try to keep this very high level, and of course we can get some questions going at the end here, but let me get into it. So everything in the green box is what everybody's flash solution does. Everybody has the performance conversation, the drive efficiency, and durability conversation solved. Everybody's going to be able to tell you that I can give you 1 million IOPS at 4K 100% read. That's table stakes in my humble opinion. What matters is everything else. Do you scale? Can you provide a highly reliable solution? And in a lot of cases, since flash arrays are displacing Tier 1 arrays in critical applications, 5 nines isn't enough. 3PAR offers 6 nines configurations with those feature sets we just discussed a couple slides ago. Is disaster recovery simple? Is it built in? Is it easy to use? And for your medical, healthcare, insurance customers, what about encryption? Is encryption simple? Does it impact the feature set? Does it impact performance? Does it drive additional utilization of the CPU? Is it easy to use? Security is built in to the 3PAR. And what applications do you integrate with? Do you have VMware, Hyper-V, KVM support? Is support built in for vVols? 3PAR has all of that. And is it easy to use? Is it not complex? Is it three, when you look at a competitor like my friends at EMC, they have 4 different flash solutions out there. Extreme IO, VNX, Unity, VMAX. How can that be simple to use? With 3 parts, 1 architecture, 1 GUI. And can you move data from your spinning media arrays to your flash arrays and back again non-disruptively? Can you import stuff from your competitors? 3PAR can do that. And is file and block built into the same solution without a gateway and without a lot of noise? 3PAR has that conversation. And folks, and I won't get into this adaptive sparing conversation too deeply, but to say that 3PAR is media agnostic. We're not stuck into using, enterprise multi-level flash or TLC or SLC or any specific type of flash, because we can use any flash platform out there. We're media agnostic, and the biggest reason we can is because of adaptive sparing. As you remembered earlier, we said we took spare space out of every drive in the system to provide that sparing. Well, in the flash space, 3PAR is intelligent enough to use that spare space to enhance the reliability, performance, and usable capacity of any 3PAR, of any flash drive put into 3PAR. And we call that 3PAR adaptive sparing. And and one of the last points I want to make about flash is we can do flash anywhere in the family. Now, folks may ask, since it's the same architecture, it's the same solution set, why do you have dedicated flash arrays? I'll point back to that Gartner flash slide. Unless it just has flash in it, you cannot get in that Gartner Magic Quadrant. So any 3PAR array that you see that has a 50 as the last 2 numbers is all flash. But to give you an example, the 8450 and the 8440 are the exact same array from a configuration controller perspective. The difference between them is an 8450 only takes flash drives, and an 8440 will take flash and spinning. So again, we can do flash anywhere in the family. You can start with a spinning media solution and add flash to it and get flash performance and be able to manage those workloads like high-performance databases and VDI that really benefit from flash. And you don't have to buy a dedicated array. And last but not least, I put this slide up jokingly, using a small old Fibre Channel or iSCSI and with flash infrastructure is like putting a jet engine on an old Chevy. Now, I'm not going to knock folks for using iSCSI and flash, but if you're using flash for high-performance databases and VDI, you really want to look at what the interconnect is between the array and host. And the best interconnect with the lowest latency with the best performance is 16 gig Fibre Channel. Can we support the other 2? By all means, but those are kind of compromises. So how is this array managed? There's a bunch of different ways to skin the cat here. We have a thin web-based client called the SSMC. That's just an HTML5 based web browser-based client that is very straightforward and easy to use. We have a fat client GUI that called the IMC that is actually going away after the next revision because, again, we all know how we love to put Java virtual machines on our management systems. You can also manage it with HP1 view. It has a fully featured CLI that you can secure shell to. Anything that you can do in the GUI, you can do in the CLI, and you can script. We also are SMIS compliant. We have RESTful web interfaces. So you can manage it from the VMware console. There's a lot of different ways to skin the cat here. And really looking at the SSMC, everything is built into that platform. There is a high-level dashboard where every piece of that dashboard is clickable. There's a search window where you can type in a host name, a volume name, whatever you want, and it will pull up every thing related to that host name or volume name. System reporting, in other words, a whole reporting function is built in. and the ability to manage up to 32 3-pars and seamlessly migrate data between those 32 3-pars is built into one management interface. And when you look at the other HP management interfaces out there, OneView, the 3-par SSMC, StoreOnce, they are all using the same interface story. And we call that piano in the piano interface internally at HP. So once you learn one interface, it gets a lot easier to navigate and manage the other interfaces for the other HPE products. And you'll see this piano interface being pushed to any product offering that HP is doing moving forward, just to have that simplicity and common management story. And what would an array be without software features? Everything in the green box in the bottom is built into the base OS. That includes things like thin, deduplication, reporting. A lot of things are built into the OS, but then there are a lot of feature sets. And I'll tease some of the startup flash players out there. I like to call them one-trick ponies. 3-par isn't a one-trick pony. We do have the integration with VMware, with Hyper-V, with SQL, with Oracle, with SAP, with Exchange, with all the applications. We also have the ability to manage data encryption, to manage common security policies across multiple 3-pars, to actually have a security suite where we can LPAR, in other words, have 1,024 virtual 3-pars in a single 3-par and have that 3-par management interface be independent between those different LPARs. And of course, the common data optimization suites like Sublun tiering with adaptive optimization, storage QoS for priority optimization, and a full-featured DR replication suite with asynchronous, synchronous, asynchronous logging, and the ability to do active DR sites with peer persistence and cluster extensions. Now, I'm not going to get into all these today because our time is limited, but I wanted to give you an idea that there isn't a lot of requirements that a 3-par cannot address. And all this is built into what we call our Inform OS. So I would be remiss if I didn't talk about thin provisioning. Thin is built into the 3-par. It's part of the ASIC. So thin provisioning is reservationless. It has absolutely zero performance impact. And it is used by the vast majority of our customers. If you look at the 3-par user base, those 40,000 systems, they average 180% over allocated. And you don't have to go thin right away. You can start thick and get thin with a capability we call dynamic optimization. DO is the capability to change the aspects of a virtual volume or one that's presented to the host non-disruptively. So you can change the RAID level, you can go from thick to thin to dedupe and back again. And you can do that all without interrupting I/O, or I/O to the host. And you can stay thin. Modern operating systems and applications have the capability to free stranded capacity. We integrate with those tightly. And it doesn't take weeks to recover that capacity. We're doing that with idle cycles throughout the day. So as your customers delete files on thin volumes, we're actually returning that space back to the free pool. And last but not least, deduplication is built into base OS and 3-par. It's inline. It is leveraging the ASIC from a performance perspective, and it scales very, very well. And I won't spend a ton of time on data reduction technologies because, again, our time is limited. But, again, dedupe's built in. It's been out for about 1.5 years now. It's inline. It is using the ASIC from a performance perspective. And you can get efficiencies, you know, on dedupe-friendly workloads ranging anywhere from 2 to 1 to 10 to 1. I don't think I've seen 10 to 1 on very many things other than VDI, but 2 to 1 with virtual machines is pretty common. Again, we talked earlier about not only offering a block solution, but we're actually offering converged block, file, and object access on the same array. With File Persona, you have the capability to add file functionality to a 3-power controller. This isn't adding an external gateway or any external hardware. It's just adding software licenses and IP interfaces to the box, and voila, you can run file and run block at the same time. And when you look at the File Persona, it's not an Isilon killer. It's not meant for the multiple petabyte systems, but we are supporting you know, up to 256 terabyte of capacity per node, so 512 per node pair. And it's got good protocol support, all the Active Directory and LDAP integration you're looking for, with users quota, antivirus built in. And it can be used and or added to any 3-power after the system's installed. But again, we still do offer 2 file solutions. We do offer the File Persona software that's integrated on the 3-power, but we also offer the 3-power file controller that's an external gateway. People may ask what the different use cases are. It really is a conversation when you want to go to you know, more than about 3,000 users. You want to go to large shared environments with 20, 30, 40,000 shares. That's when we start to point people to the file controller, because they can start at a single controller, cluster to 2, and go up to 8 nodes in the file controller story. So I think we're doing pretty good on time. Let's jump on some recent storage announcements. One of the first ones I like to throw out there is we just announced a 15.36 terabyte SSD drive at Summer Discover. There is nobody that's even coming close. We are actually shipping today a 7.68 terabyte drive, and my competitors are just starting to get there. So when you're talking the ability to do 480 drives, 2.5-inch drives, and do 15.36 terabyte drives, you're not talking multiple petabytes. You're talking a ton of petabytes in a very small rack footprint. It's with the 3.84s, we were going well north of a single petabyte of available disk to customers in under half a rack, and that's the 3 petabyte. When we get to the 15, it gets very, very crazy. And I think what you're going to see in Flash is really bending the curve on capacity growth per drive. Flash is doubling every 6 months in capacity, and will continue to do that. And since 3-power is a media agnostic data mover, we can implement those new drive footprints non-disruptively without any forklift upgrades in the 3-power system. And you can mix drives in the 3-power system. So I have customers that have 1.92s, 3.84s, and 7.68s in the same system. And not only do we have deduplication, we also announced compression capability. This will be added to any customer that's running a Gen 5 8,000, 20,000 series system. Again, like I mentioned earlier, we try to push these feature sets as far back as possible, but compression is a very ASIC-friendly conversation. It pretty much runs in the CPU. So we only could get that ported back into the 8,000 series. So for any customer that's bought an 8,000, compression will be added to the platform here at the end of the year, just as a straight-up code upgrade. And being able to use dynamic optimization, or DO, we will actually be able to move thin footprints or thin deduplicated footprints to thin deduplicated compression footprints. So let's kind of summarize what we talked about on compression. Compression is per volume. It does require thin. Again, it's a Gen 5 8020K story only. It's going to be firmware update, and we're not going to be asking for any additional dollars or licensing. Any customer that's running 3-power 8Ks will get this as an upgrade at no cost to them. Again, it's initially only supported in SSDs. Again, it's pretty easy to implement those technologies in SSDs because SSDs have a lot of performance to burn. It does have the potential to support 10 and 15K SAS media later on, but it won't be initial release. It uses all the existing metadata structures in 3-power, so we really didn't have to redevelop the wheel. And again, you can compress existing volumes that the customer already has with DO. The one thing you have to remember about any data reduction technology is it's not friendly with sub-1 tiering tools like autonomic optimization or AO. So some closing thoughts, and my God, I'm actually going to be on time today. That happens very, very rarely. What's the 3-part differentiators? Why 3-part? You know, it's a single modern efficient architecture from mid-range to tier 1. And, you know, from product family, 7,000 to 10,000 to 8,000 to 20,000. Has the same tools, same management capabilities from the 30K array all the way to the multi-million-dollar array, including flash. We didn't have to buy a startup company from Israel to implement flash. We actually just built it into the existing solution. Thin deduplication and soon-to-be compression are built into this solution, with the ASIC handling major portions of those to offload performance requirements. It's a true active-active controller architecture. All controllers are active to all disks, to all LUNs at all times. There's no LUN trespassing or failovers, and there's no white papers on when to do thin, thick, what you're doing there. Everything just works. It's back to that simplicity story. The other thing is we do publish industry benchmark results. Go out and look on the 8K, the 20K, and we're constantly publishing new results on platforms as they come out. It's simple to manage. I can show anybody on this call how to do basic storage allocation and DR functions in about 15 minutes without a ton of professional services. It's easy to use. Now it isn't like a lot of the what I would call one-trick pony flash players where they have 3 buttons and 2 dials and 1 slider. There are a lot of menus, there are a lot of things going on in the 3-part GUI, but because there are a lot of features that we can manage. And last but not least, robust high-performance simple DR is built into the solution. Every 3-par has an IP interface. It's a gig on an 8K, a 10 gig on a 20K. And if I can ping another 3-par, I can DR it. And I can set up that disaster recovery job in 15 minutes. We also can replicate via Fibre Channel, or we can do a mix. And we can do extremely complex replication scenarios, you know, up to 4, you know, 1 3-par to 4 different 3-pars. And we can do synchronous, asynchronous, async journaling, the whole 9 yards, and active-active. And voila, I am done on time. Questions?
Thank you, Pete. That was a perfect, wonderful presentation. I don't see any questions as yet. If you have got any questions, please enter them into in the question box now, and Pete will be more than happy to answer those. Okay. So I don't see any questions there. Thank you so much, Pete. If you still have any questions after the presentation, you can send us at mec@onpoint.com, and we'll send it to our speaker, and he will be more than happy to answer those. So with that, thank you so much. Thank you so much, Pete, for joining us and giving us a wonderful presentation, and thank you for all the audience who have joined in. So, and have a great rest of the week. Thank you.
Yeah, thanks.